Hi everyone, this is Costa here from InsightStat, and welcome to this new video where we are going to talk about another important filter expression or a filter function. The name of the function is filter function, right? So let's see what filter does. So filter creates a subset of data by evaluating each row against a condition, right? So this is a table function. It evaluates a table. It will look into a table row by row, and there will be some condition that would be involved, which it would measure or it would evaluate each row against. Whichever row returns a true to that condition will be returned in the subset table, right? So as I said, this is the filter function is a table function that returns a filtered subset of rows from a table. Again, it evaluates a table based on specific conditions, right? So let's look at in more detail what the syntax says. So we have the table. So this is the table that we want to filter, and it can be any table. It can be the customer table, it can be the product table, it can be the territory table, it can be any table that we want to evaluate. Now, what do we evaluate this table against? We have to evaluate this table against some filter expression or some condition. So this filter expression or the filter condition is a logical expression that determines which rows from the table parameter, that is the first parameter, will be included in the result. So whichever rows returns true to that condition or meets that condition will be returned in the subset table. Now, this expression or this condition must always evaluate to true or false for each row in the table. Very important to remember. It creates a row context automatically within that row, and it can contain complex logic using operators like the double ampersand or the pipe. The double ampersand evaluates to and, the double pipe evaluates to or, right? So these are some of the conditions that we have to keep in mind when we are evaluating the filter expression. So this filter expression can be something like this: sales amount greater than 1,000, or a product category that we are evaluating to a certain product category, for example, electronics, or we are looking at the product price, which is greater than the overall average price, and this is a measure, right? So we will see how this filter function is different from calculate, right? So what calculate does is calculate brings in a filter context, but it is not evaluated row by row. It gives us a scalar value, whereas filter evaluates a table and it evaluates the condition row by row. Okay, but having said that, when we move into an iterator function, and you would see that an iterator function also moves row by row, evaluates row by row. So the question that should come to your mind is filter an iterator function? Hold on to that question. We will answer it in the next video when we start off with the iterator functions. But as of now, we will only talk about filter function. Okay, and filter function evaluates the condition row by row, and it returns us a subset of the table, right? Enough talk, enough theory. Let's go to Power BI and look at how filter is evaluated or how filter is put into action. Right. Okay. Now let's take a scenario here. Let's say I bring in a matrix, and in this matrix I have the category name. And remember, we had this average retail price. Let me bring this average retail price as well. So this is the average retail price by category, right? And in this case, we have the filter context, which is nothing but the category name, and we are looking at the average retail price. This is the overall retail price. Okay, now if I want the overall retail price to be displayed here, how do I do it? I think everyone knows by now how to do it. We have to evade the filter context here. So how do we evade the filter context? So I'll go to a new measure and I'll say overall average price, and this overall average price will be calculated using the calculate function. I will use the average retail price, and I would say that I would not want this average price to be broken down by the category. And the category, of course, comes from the product lookup table, from the product categories lookup table. We can use the product lookup table here. So I can say all, and within all, within all, I would either name the table or the column. So I would name the product lookup table, close the parenthesis, and close the next parenthesis, and we have the overall average. Everything looks fine. Let me select this visual and bring the overall average price. So look at this. So the overall average price, let me format this. Overall average price should have up to 2 decimal places. Right? Okay. Right. Now, so the overall average price returns the same value for each of the row items. So which means we have successfully evaded the filter context. Now, the ask from the business is they want to look at those categories, or they want to look at those individual orders which is greater than the overall average price. So how many orders in accessories are greater than the overall average price? How many orders in bikes is greater than this value? How many orders in clothing is greater than this value? How many orders in components is greater than this value? So that is what we want to calculate, right? So again, we'll go ahead and click on the new measure, and let's call these items high valued items. High valued items. And I'll say calculate. I'll want to calculate the total order quantity. I want to look at the total order quantity where the product price is greater than the overall average price. Let me close the parenthesis and enter. Look at this. It's a very intuitive error message that Microsoft gives us. A function placeholder has been used in a true-false expression that is used as a table filter expression, which is not allowed in calculate. This is exactly what we talked about when we talked about the calculate function. Calculate would not allow this, right? So how do we rectify this? There is one easy way of rectifying this, since it cannot evaluate another measure in the Boolean expression, but it can take a Boolean expression, and we know this Boolean expression is 714.44. Now if I do this, it works, right? So if I bring this high valued items, so this high valued items, let me put a comma here, and I bring it over here. See, it works. Only bikes as a category is contributing to high ticket item orders, right? 11,312. But do you think this is a long-term solution? What happens if some new product comes in, we introduce a suite of new products, and it impacts the overall average price? So do we come back here and do any other function that is evaluating this expression, we would have to come back and replace this value every time. So this is hard-coded. Anything hard-coded is not a very good way of coding. So how do we do this? Now this can be achieved using the filter function. How do we do it? So I can say calculate the total order quantity, but before that, filter which table? Filter the product lookup table, and we will look at the price, the product price of each item, which is greater than the overall average price. Right? Let me close this parenthesis and click on enter. Did anything change here? Nothing changed, right? This is still working because now we have leveraged on the filter function. So if we go back to the formula again, so what did we do here? We told filter that filter the product lookup table. And how do we filter? Each row will be evaluated against this criteria, this filter expression. Each row of the product lookup table will be checked whether the product price in each row is greater than the overall average price. If it is, the subset table will only have those fields in the product lookup table that agrees to this, and whatever is left, whatever subset table we get, the total order quantity will be calculated on that table. So this is how filter works. It's very powerful, but please also remember, since it evaluates row by row, it is computationally more expensive than calculate, but won't matter a lot if you are working with manageable data set, maybe 10,000, 20,000, 30,000 rows of data. That won't make any difference. But if you go for bigger data sets, then it might make an impact. But it is also very powerful because it evaluates each row of a table and returns us a subset of the table, right? So this is one of the first examples that we are talking of iterator functions, kind of iterator function. We will talk about the core iterator functions in the next video. In this video, all I had is this. If you have any questions, just put it in the comment section. I'll be more than happy to answer. Thank you so much for watching. Bye-bye.